These are the basic principles of broaching. It is a machining process for removal of a layer of material of desired width and depth, usually in one stroke by a slender rod or bar type cutter having a series of cutting edges with gradually increased protrusion, as you can see in figure which comes here. It is in shaping. Attaining full depth requires a number of strokes to remove the material in thin layers step by step by gradually infeeding the single point cutting tool. In figure B you can see, whereas broaching enables remove the whole material in one stroke only by the gradually rising teeth of the cutter called a broach. The amount of tooth rise between the successive teeth of the broach is equal to the feed given in shaping. Okay, so here you can see in shaping we give so many cuts, but in broaching just you are supposed to do one stroke and you will get the required depth. So here you can see the next is the basic principle of broaching. So this is vertical push, it is inserted into the workpiece, and this is the horizontal pull. This is pull to the left side to achieve this much required hole. Okay, this is the geometry of broach tool. Here you can see the pitch, shank length. So the different types of broaches and their applications. So broaching is getting more and more widely used wherever feasible. For high productivity as well as product quality, various types of broaches have been developed and are used for wide range of applications. So broaches can be broadly classified in several aspects such as internal broaching or external broaching, push type or pull type, ordinary cut or progressive type, solid sectional or modular type, profile sharpened or form relieved type. So here internal broaching tools and their applications, which includes internal keyway, splines, non-circular holes, internal slots. Here you can see. Okay, so these are the broaches are used to get such shape. Okay, this is what the internal broaching is there. Now let us see the next, external broaching. So external surface broaching competes with milling, shaping and planing, and wherever feasible this process outperforms in respect to productivity and product quality, and this may be of both pull type and push type. So main applications of the external broachings are surfacing flat peripheral contour surfaces, grooves, slots, keyways, etc. on through the outer surface of object, and also for external splines of having different forms, and the teeth of external spur gears or gear sectors. Okay, so let us see next the pull type and push type broaches. Pull type broach is subject to tensile force which maintains alignments and prevents buckling. Pull type broaches are made as long as single piece, and these are widely used for internal broaching, and push type broaching are shorter in length to avoid buckling and made in segment. Push broaches are used for external broaching, preferably requiring light cuts and small depth of material removal. So here ordinary cut and progressive type broach is there. So here you can see the solid sectional and model type broach. Now these are the types of broaching machine according to purpose of use: general purpose, single purpose, special purpose, and according to nature of work: internal broaching, external broaching, and according to configuration: horizontal, vertical, according to number of slides or stations: single station type, multi-station type, indexing type, and according to tool or work motion: intermittent type and continuous type. Now next we are going to see the planer and boring machine. So here you can see the planer. This is the difference between shaper and planer. Planer types: boring, which we have seen. Okay, so boring, we know that it is the process of producing circular internal profiles on a hole made by drilling or another process. It uses single point cutting tool called a boring bar. In boring, the boring bar can be rotated or the work part can be rotated. Machine tools which rotate the boring bar against a stationary workpieces are called boring machines. Also boring mills also. Borings can be accomplished on a turning machines with a stationary bar position in the doorpost and rotating workpiece held in the lathe chuck. Okay, so this is what the cutting conditions in boring. Now that is the let's see the types of boring machine: horizontal and vertical boring machine. Now next we are going to see the MCQ. So here we are going to see the MCQ on the first unit. So let us see one by one. I will directly say the answer instead of saying all the options. I will tell only the correct answer. In metal machining, the zone where the heat is generated due to friction between the moving chip and the tool face is called a friction zone. Option A, friction zone. Now second question: in determining the various forces on the chip, merchant assumed that the here the option D is correct. That means all of the three options sentence are correct. Okay, now let us see the next question. In machining metals, surface roughness is due to and the answer is option D. All three sentences are correct. Okay, so question 3 is D option is correct. Now the question 4: the tool life decreases as the cutting speed increases. Okay, as cutting speed increases, tool life decreases. Now next, in the relation Vt raised to n is equal to C, the value of n for high speed tool varies from 0.25 to 0.40. So option is B, disagree. Okay, now negative rakes are used for all these, that is for carbide tools, heavy loads, harder materials. Now option C, which statement is correct about nose radius? That both the statements are correct, option A and option B. Okay, so C option is correct for the question 7. Now 8th question: in order to achieve a specific surface finish in single point turning, the most important factor to be controlled is option C, feed. Now next, the tool life is said to be over if here the option D is correct, that means all of the above. Okay, So next question, continuous chips with built-up edge are formed during machining of ductile materials. For question 10, option B is correct. Ductile material metals. Now next question, the rate of removing metal is increased by increasing the depth of cut. Okay, as depth increases, the removing metal is also increases. Now 12th, the tool life is dependent on cutting speed. Okay, now next, the factor sum of cutting velocity and chip velocity is equal to shear velocity. So option A is correct. Next question, in an orthogonal cutting, the depth of cut is halved and the feed rate is double if the chip thickness ratio is unaffected with the changed cutting condition. The actual chip thickness will be doubled. 15th question, the spindle cutting energy used for establishing the machinability of the metal depends upon the all these three factors. Okay, option D is correct. Which of the following parameters govern the value of shear angle in continuous chip formation? So here also all of these, option D is there for question number 16. 17, the shear velocity is the velocity of, here none of this is there for question number 17. So for 18, in metal machining, the zone where the minimum heat is generated due to the plastic deformation of metal is called as the shear zone. A better machinable metal is one which gives lower chip tool contact area and larger shear angle. Okay, so for question number 19, option A is correct. Now question number 20, the correct sequence. Okay, so here the option C is correct, cutting speed, feed rate and depth of cut. Now next question, that is the cutting fluid mostly used for machining steel is soluble oil. Okay, the lip angle is the angle between the tool face and the ground end surface of flank. So next question, small nose radius results in excessive stress concentration and greater heat generation. As the next question, as the cutting speed increases, the cutting tool forces decreases. Next question, crater wear leads to, here D option is there, that means it leads the above three effects. Okay, so 26 number question, the relation between the tool life in minutes and cutting speed in meter per minute is depends upon the tool and workpiece. Okay, so the correct answer is option B, Vt raised to n equal to C. The tool life is measured by the all these factors. Also for 27 number question, option D is correct. 28, crater wear is mainly due to the phenomena known as diffusion of metals. Flank wear depends upon the amount and distribution of hard constituents in the work material. And next question, the tool may fail due to, the option is option D, all of these. Now next, the factor considered for evaluation of machinability is, here again the option D is there, all of these. Now next question, in machining metal, cutting force at the cutting edge is measured by, okay, that is tool dynamometer or dynamometer, option B. Okay, in American Standard Association system, if the tool nomenclature is 8-6-5-5-10-15-2 mm, then the side rake angle will be 6. Okay, option B is there. Now, in oblique cutting of metals, the cutting edge of the tool is here inclined at an angle less than 90 degree to the direction of tool travel. Now next question, cutting fluids are used to, the option is D, all of this. And last question, tool life in orthogonal cutting is less than the tool life in oblique cutting. Okay, so here today we are going to stop over here. Thank you.